I'm a solutions engineer at HashiCorp out of the Boston area, and I'm going to do a little bit of a history lesson, I guess. So, back in the day, depending on when your experience with tech started, you probably were talking about hardware. We're just racking and stacking servers, we're connecting switches, routers. It's all about getting under the floor and running wires, things like that. It's very hard to deploy, right? You have to really plan this out, kind of like building your castle. It's very slow, but it's sturdy, and you don't ever think about tearing it down because it was so hard to put together in the first place. So the currency here is really real estate. What you need is space. You need enough space that you can have a lot of servers that are going to stay cool and not overheat, and you can space them out, and you can have hot rows, cool rows, but it's really all about space. How much can I pack into that rack? And that's sort of how we did tech back in the day. Then we found the hypervisor. So now we said, we can build parts of this castle ahead of time, not when we need them, and then we can cut it up as necessary into nodes. And really, nodes are just a collection of some amount of storage, some amount of CPU, some amount of memory with some network that lets you get to it. And so this part really thrived. We got into this node is king kind of thing where if I need a project, what does that translate in terms of nodes? Because that's the cost that's associated. Or if I'm building a sandbox, I need to put in a ticket for 5 nodes or 6 nodes. So it's all about nodes. So that became sort of the currency. And this is where the concept of infrastructure as a service or infrastructure as code really took hold. And this is where Puppet comes in, because Puppet is really good at this. It's good about writing code declaratively, reaching out to nodes, classifying them, executing code, and configuring things the way that they need to be, and then being able to report on them. So this is my world up on the screen. I'm really just looking at node by node, but then we start moving into other things like public cloud, where this kind of changes. We have potentially unlimited storage, potentially unlimited CPU and memory. It just depends on how much we're willing to pay for. But with this kind of model, now we're talking self-service. Now we don't want people to just ask for nodes that get automatically configured. We want them to be able to ask for nodes and get them immediately, or rather immediately. And not only that, there are things, if I zoom out, there are things about this model that fall into that self-service category. So now not only do I need a node, maybe I need a VPC that goes along with it. I need to put this in a particular security group. There has to be a load balancer in front of it with DNS and maybe even some CDN. And then as I do this, if I'm going to let people build on demand, I need to make sure that I don't forget about logs and monitoring, because I don't want to lose sight of what's going out there and what's breaking and what's failing. And so this is becoming a bigger picture of infrastructure as a service. That type of model has now changed a little bit. And then as we expand our world a little bit more, we're not just now talking about infrastructure as a service. There are other things that people need sort of on demand, self-service in this way. Platforms as a service. Maybe that's Kubernetes. Maybe it's Lambda or serverless functions. Maybe that's deploying an app to Heroku. So a lot of other things going on here that we need to think about. And then if we go even further, this is not even maybe all the stuff that we need. There are softwares as a service out there, things that maybe are not part of the infrastructure, so to speak, but they go along with the projects that you're building. So end to end, when I deploy a new sandbox, I need a GitLab repo provisioned along with that, or I need an SSH key that's attached to those servers, or it's going to reach out to Datadog and get some monitoring configured there. So there are other things now that fall into this. I need it now, and the other flip side of it is after I'm done with it, I want to be able to destroy it and decommission it rather quickly. So this sort of paints a new, what I call like a landscape of technology. And so we need a new operating model. And this is something we call the cloud operating model. So this is a way that we build a practice to now sort of cross the board be able to build these things on demand using the practices that we developed in infrastructure as code. We want to do this declaratively. We want to use version controlled code. We want to use like a Git flow with pull requests and approvals, and that way we can track everything that we did back to who did it, which commit hash, which feature branch, so on and so forth. So I'll flip over to some slides just to paint the picture. Don't have that many, I promise. So I'm gonna sort of set up a scenario here. So I'm working at a Puppet shop. I've got Puppet Enterprise, let's say, already deployed in my data center. I'm looking at going to AWS, and I want to adopt this new cloud operating model. So here are my challenges. Number one, I know how to build a server in the data center. How do I build a server quickly in AWS? And not only that, there are some assumptions that go with Puppet. I need network, right? I need to be able to reach that Puppet master. I need DNS resolution to be able to reach that Puppet master. I need NTP to be working, and all those kinds of things. There are some assumptions that are there in order for Puppet to even begin to work. After I have the master, I have some of the same challenges with provisioning the actual Puppet agents and nodes themselves. How do I get those machines working? How do I get the agents installed? How do I make sure they have a pipe to the master? They have DNS that resolves where the master is. I got to get that agent installed, and then I got to configure the agent to let it know how to reach the master. So a lot of things going on there that now I have to reimagine how I'm going to do in the cloud. So here's some components that I'm going to work with. I'm going to use Terraform. Terraform is going to allow me to build all these different types of things that I have in my landscape. I like to say if you have an API, we can Terraform it. And if you want to Google this later, look up the Terraform Domino's pizza provider. So you can actually write code declaratively to order pizza because Domino's gives you an API to do so. It's weird. The next thing we're going to do is we're going to use the Terraform Puppet Provisioner. So now in Terraform, we can describe the configuration of the Puppet agent that's going to be installed on that machine. And actually the way that this is being done is the backbone of the Puppet provisioner is Bolt. So Bolt is already set up to be able to remotely log onto machines, install the agent, and configure that agent with whatever it needs, certificate extensions, issue a CSR, and reach out to the master. So we're using that behind the Puppet provisioner, but the provisioner basically allows you to describe it in Terraform code just as you would any other object that you're trying to build. And then lastly, of course, Puppet is the fourth component. It's actually going to fire off, get a catalog, and configure the machine. The easy example that I'm going to show you today is just a WordPress example. One machine running Apache and PHP, talking to a second machine with a MySQL backend where WordPress is going to keep all its data. So I'll flip over to some code. There we go. So this is the code that I use to provision the Puppet master. So generally all code starts off with a provider. Similarly in Puppet, where you write in terms of types, and then that translates to a provider, which is the thing that's actually going to execute all the API calls to whatever the backend is. Similar model here. I'm saying that I'm going to write code that's target is AWS. So I set it up as a provider. So here I'm deciding I'm just going to create an SSH key, a private and a public keys, rather than uploading my own key. It's just going to create one that goes along with this sandbox. Next thing that I need to do is I need a pe.conf. So I'm going to template that out. Really the only password, really the only variable in this template is going to be the password, and I'll show you where this comes up later. So I want to be able to SSH to the machine from anywhere. This is a terrible practice, but I'll do it just for this demo. I need to be able to hit the console, and I need, of course, 8140 to be accessible for Puppet to do its thing. So I'm building an Ubuntu image from Canonical, and then really this is the meat of what I'm doing here. So I'm building this instance. I'm supplying some user-supplied variables, and then some data that I'm doing. So, for example, I'm dynamically pulling the latest Ubuntu image and then using that. I have my security groups, being responsible, and I'm tagging my machine. And then I'll describe how do I actually connect to that machine, because what I need to do is I need to copy that templated PE-conf onto disk so I can use it. And then I can, I need to swap in the actual public DNS name so that when I do the PE installer, it uses the proper value. And then I'll actually grab the PE tarball, I'll extract it, copy some files off, and in the end, I'm just going to actually run a script which is pretty much what you'd expect it to look like. Is I'm going to run the Puppet Enterprise installer. I'm going to install my Node Manager module just to make it a little bit easier to create some stuff later. I'm going to create some roles for Code Manager to work, a deployer role. I'm going to fetch a token so that Code Manager can actually work. I'm going to trigger my initial code deploy, which is going to download a bunch of modules, of course. So I'm going to update the classes that are then available in the PE console. I'm going to create some groups. And then I need auto signing. Again, the way that the Puppet provisioner works is we don't want that stop where I build 10 nodes, they come online, I need them now, but now someone has to go in and actually accept those certificates. So in this way, I can use the auto signing module to do some sort of token handshake where I can verifiably say this node can be auto signed because it was built with a secret key as it was provisioned. And that's all handled by Bolt and the auto signing module. All right, so the next thing that I want to show you is the variables. So just like in Puppet, I can add variables to my code just to make it very flexible. I decided I'm going to be on 2019-02. I'm using Ubuntu, so on and so forth. But the thing I want to show you here is for that password variable, I have a default value in there. So this is a terrible practice, but I'll show you how we're going to modify this in practice. So I'm using Terraform Cloud to provision my master. And Terraform Cloud is just a free UI server-based application of Terraform where I can keep track of all my Terraform states and all my Terraform runs, similar to using GitHub as a central service versus running Git just locally on your own laptop. So I've built the Puppet master here already because it does take some time. And what I want to show you as part of my apply, one of the outputs that I have is the actual DNS name of the Puppet master. And the reason I've done this is I want to make it dynamic. So I want to be able to produce a value using this module that can be consumed by other people or other Terraform code. So rather than having to sort of announce this value, email it to folks, or have it be documented in my wiki where people have to go access that value, it can be an output. So this is my Puppet master Terraform code. It takes inputs and then has outputs. And then the Puppet agent code will use this output as an input. So it's really just like an API-driven data flow almost. So I don't have to worry about hard coding values. Then I'll take a look at variables. And so this is in the Terraform UI where I'm going to supply an override to that admin password variable. And I'm going to mark it as sensitive, which means after it's been committed in here, no one can actually read it. The best you can do is overwrite it if you have access. So that way, no sensitive values or no passwords or SSH keys in plain text, and we can hide those away, except for the proper people that can come and interact with that. The other thing is, instead of issuing a set of AWS keys to any and every user that's building, we can come here and centralize that information so that when I run Terraform on my laptop, it's actually streaming the execution through Terraform Cloud. So those keys are stored there. And as an operator, you could rotate those keys every 30 days, every 2 weeks. And it's really transparent to the user that's writing code. They need a token to gain access to cloud, but they don't need to know what AWS keys to use, or they don't have to have their own keys that they're using in order to execute. All right, so flipping over to now the agent code. So I have an output that's in that workspace, which is the name of the puppet master. So the first thing I'm doing is I'm going to data source that. And that's basically what's going on here. I'm going to go to some organization. I'm going to look for some workspace, and that's going to be a data source called PE. And I'll show you later in the code where that gets used. So a lot of similar stuff here. We need a security group. This is the database server. So I've got 3306. I'm going to actually build that database server. And let's scroll down to where we actually use the Puppet provisioner. And that's here. So this is how I'm sort of dynamically pulling that Puppet master name, is I'm using the PE data source. I'm looking into the outputs, and I'm grabbing the one that's called Puppet master. So now, again, I don't have to hard code it. If I want to reuse this code in one AWS account versus the next, because I probably have multiple in my organization, and that way I can dynamically source that Puppet master name. The next thing that I'm going to do is I'm going to embed in the certificate an extension for PP role. So this is a common pattern for classification, is that when I build a machine, in the certificate I will embed a role, and then the Puppet Enterprise Console will look for that role and then classify the machine based on that. So that's something that I can embed here in code. The next thing that I have here, just as an add, because when I was building this, I was building and destroying very frequently, is I have a provisioner that when I destroy the machine, I'm actually going to go and purge that node based on the name that it's given. So that way, if I want it to disappear quickly, that's great. If not, I can leave this part out, and then when that node times out according to your settings, it'll just get dropped. But adding this bit here at least makes it go away, especially if I'm going to be purging it and building this node 10 times a day. I don't want to have to maybe have overlap in the console. So similar thing going on for the web server. Again, I'll scroll down to the main difference. I'm still using that dynamic data source to find my Puppet master. I've got a role of web server, and then I'm doing this here. I'm going to give it another trusted fact of PPE application. I just used one at random, but what that is going to have is it's going to look for the DB server AWS instance, and it's going to grab the private DNS name. So again, I don't have to build the database server and then find out what the host name is. A lot of times in our clouds, we don't know what the actual host names are. They just get randomly assigned unless we do a bit of work to actually set the host name ourselves. So you just grab whatever that value is and feed it into the certificate so I can pick up on that later. Another way people pass information like this is maybe dropping it into the tags of the machine, and then we can use the EC2 tag fact that's in Puppet to pick up on that. I just decided I'd throw it in the certificate. And what this also does for me is if we have the case where I need to build the database server before I build the web server, because if I build the web first and the database is not available, the app will just crash and it won't retry. If there's that dependency here, by virtue of me saying that I need to wait for this value for this to be able to be built, Terraform is going to put that in order. Very similar to dependencies in Puppet, where I need to build the group before I can put the user in that group. Similar things going on here. Terraform is going to compile this and say, okay, because you need this value, I need to build a database server first. And then the same thing, when I destroy this node, I want to be sure to purge it on the way out. Okay, so I'll show you a video demo because this does take a while. I didn't want to just sit here watching this build very slowly. So I'll run a Terraform apply. It's going to pull state. It's going to start building. And maybe I'll skip through this a little. You see it SSHing to the machine. That's the Puppet provisioner. So after the Puppet provisioner starts firing, we'll see it start to load everything that Bolt needs to get going. Bolt grabs the agent. We can see now Puppet's starting to work. This is where I get a CSR. It gets auto-signed, all the Puppet install stuff happens. I'm going to start loading my facts, getting a catalog. We see now the MySQL install begins. database server next up. We see that the web server gets created, and I'll slow this one down a little bit. And this is Bolt doing its thing, unpacking and installing the Puppet agent. Then Puppet starts taking over, doing its thing, and then we're able to request a catalog. And after Puppet is done loading all its plugins and requesting its catalog, we'll see now this is going to fire on an Apache installation. There we go. And then in the end, we're configured to spit out the location of the WordPress machine. So I'll actually grab this from my terminal where I ran it earlier today. And now I've got my WordPress machine. So one thing that I wanted to show as to how we're picking this up is I've got a profile here for the website of WordPress, and I'm passing as a parameter to that, picking up on those extensions. So I'm going to look for that PP application trusted fact, and I'm going to feed that into the WordPress module as to where my DB host is. So that's one thing. And then I also wanted to show the classification. Take a look at web servers. So yeah, looking for that PP role fact. If it's equal to web server, that's where this machine is going to fall. And we'll install whatever classes I need with whatever parameters that follow. And as you'd expect, over on the DB server side, same thing. Looking for a role that's set to DB server, and then I have some configuration that I've done in the console for that as well. So that's how I'm tying these two things together, using the role and then the PP application to pass the database name around. So the last part of this is when we build something, we can't forget about it, because if we do, then we're just going to burn money on it, right? So we always have a case, or a lot of times we have the case where somebody says, like, why are we spending so much money on cloud? Let's clean up our instances. So we're going to go and we're going to find things that have been long running. We're going to see if they're tagged, and if they're not tagged, we have to go email the team, like, whose instance is this? If we're not using it, please shut it down. Good thing about Terraform is everything that it builds, it's remembering that it's being built. So it has that life cycle sort of built in. So what I can do is everything, oops, that's my video. Everything that I've built using this set of Terraform code, it's recorded in state. And you can keep the state on disk. You can use Terraform Cloud to store your state. You can do things like put them in S3 buckets or other kind of blob storage, but this state is going to be a record of all the things that I've created. So when the time comes, I need to be able to know where that is and at least store that state securely. I can destroy this, and in this way, Terraform is going to say, okay, everything that you built for this project, I know what it is. I'm going to go and get rid of it. And if you have actually gotten rid of it manually, it'll realize that as well. So if you did go into the console directly and delete like an EC2 instance, it's going to pick up on that and say, okay, that's already gone. I don't have to actually worry about that. But the other thing I wanted to show here is on the way out, it is going to connect to the Puppet master, and it's going to run the purge command. And we see the output that you would see if you ran this yourself about, yep, we're purging the node, but you probably want to delete the certificates from other places as well. So that will remove it from the console. I'm going to do this for the web server and then the database instance. And then we should see these things drop out of the console. There we go. Yeah, we'll let that run. Actually, I wanted to go back to this. So in the end here, we do have a use case for Puppet. We still need to grab our nodes and manage them, patch management, make them unique to the function that they do. We may have images where some of these things are already baked in, but it's very hard to have an image for every single type of thing that we have in our infrastructure. So we use Puppet to then sort of put the icing on the cake. But if we need to go end to end in some of these other areas, we want to be able to use something like Terraform now to sort of build a landscape and then fill in all the uniqueness with Puppet on top. So I don't think the two are as much competing as they work better together in that way that we were mentioning before. It was like let's have everything kind of speak the same language, and that way we can play on each other's strengths. And that's all that I had.
All right. Great talk, Ranjit. So I had a couple of questions here. One is a very specific question about some code you're working on. You had a relationship on a database, and Tommy wants to know if you rebuild that database server, is that going to also rebuild the app node that depends on it?
Yeah, that's a good question. It won't. The reason being is this provisioner that's let's see. When I build the EC2 instance, it's in state. It's going to be recorded that that thing was built, and it's already there. And as far as what that database instance name is, that's not a thing that Terraform cares about so much as it's just passing it to Puppet for Puppet to use. So after it's initially handed off to Puppet, Terraform's not sort of keeping an eye on that. That's merely like a pass through, if that makes sense.
It totally does. And I'm sure that Tommy will follow up with you later on if he has any more questions. And then the next one is not really so much a question, but more like, hey, maybe we could sort of like start a dialogue and talk about what this would look like if you were trying to do this at scale. Brian says that it looks like a really, really great idea, but he's not quite sure how that it would work when you've got multiple development teams that are all trying to coordinate here.
Yeah, I think that's where hopefully a tool like Terraform Cloud comes in, because I've just got one workspace here, but this is where you would have, maybe hundreds in this list, and you could attach them to repositories, to specific branches of the repositories. And if you start to track workspaces in cloud, that's where you could say something like, if this thing fires, trigger the next one, and then trigger the next one. If we're doing Terraform locally on our laptops, sort of like I did in the video, we can't really link all that together, so we lose some of that scale there. So that's where a tool like Terraform Cloud can centralize that and be able to relate things and control access on them and all that kind of stuff.
Okay, that sounds good. And there's not like a whole lot of concern about destroying other people's instances because you've got access control set up for that already.
Yeah, exactly.
Right on. I'm sure that Brian will actually follow up with you. He just posted, he says, I really wish I would have understood this a few months ago. One more question for you, and it's kind of about the whole sort of workflow process. How does Puppet help when you're doing something like managing a Lambda function in terms of CI and CD?
Yes. So that's where like when I'm looking at this landscape, so I think I don't want to like bash Puppet because this is a Puppet camp, but I think you want to use the tool for what it's meant to do and where it's strongest. So I think with Puppet, awesome at nodes, and then because of its pluggability, you can have it reach out to other things and configure more than maybe its strength. And so you start to see some funny things happen. And that's where maybe a tool like Terraform can come in and do that instead. Now, like the question about the database before, if I tried to use Terraform to configure the database name after a machine was provisioned, I could do it, and it would be really weird, and it's not where Terraform's strength is. So that's where we want to make the things work together rather than sort of like go to these edge cases and start doing some wonky things, I think.
Yeah, agreed. I really like integration between tools so that you can play to each tool's strong point. That's part of the reason why I was so excited to see this talk.